Hello, this is Dr. Sturm talking you through the Unit 2, Day 1, The Life Cycle of the Stars assignment. So stars are born and they live their lives and then they die, and the processes that they undergo are generally similar. Some stars have short lives, others live a very long time, and some kind of die quietly while others die very violently. What remains of a star when it dies varies, and the life of a star, the life cycle that it has, is determined by its mass. So here is a video you can click through on this assignment and watch. I recommend that you do that as we work through it. And here is a nice diagram that looks at the life cycle of a star. It starts as a nebula, which is a dense region, and that some part of it begins to contract, creating a protostar. That leads to it turning into a main sequence star where the star gives off light and heat, and fusion begins in its core. Now, from that point, it depends on the mass of which direction we're going to go. Are we going to go the upper direction? Those are high mass stars, or down on this lower level, the lower mass stars. So our sun in our solar system is a lower mass star. So let's do the bottom one first. And when you have a main sequence star like this, eventually, as it is burning hydrogen or fusing hydrogen into helium, once it uses up all that helium, something different will happen, and it will actually expand and then cool and redden and become a red giant. Once that phase is done, and in our case, that's going to overtake Mercury and Venus and come, and Earth as it becomes a red giant and expands out. It will then have an expanding gas shell with an intensely hot core. It'll be a planetary nebula, at which point it will then the core of the sun will be left over, and that is called a white dwarf. That core turns a bit red as it cools, becomes a cooling white dwarf, and eventually the core stops glowing altogether and it becomes a black dwarf. Now let's circle back and go to this main sequence star, but this one would be a higher mass star. Well, then it's going to have a different path, and it's going to go up to the top up here. In that case, once it has burned its fuel in terms of the fusion in its core, it is going to greatly expand, getting redder as it cools, and become a red supergiant. Once that collapses back down, it goes supernova. The outer layers of the star are blown away in a gigantic explosion, and this is where those higher elements in the periodic table are the only place that they can be created, or in supernova explosions. Once the supernova explosion dissipates, the core shrinks and becomes incredibly dense. And you can it can become a neutron star, which is an incredibly dense celestial object. Again, you can see only about 10 miles across, but incredibly dense. Or they could become a black hole. There we go. So that is that diagram about the life cycle of a star. So let's work through this assignment right here. So according to the diagram above, number 1, stars are born within a great big cloud of gas and dust called a nebula. And there's a picture of a nebula right there. Number 2, the force that pulls that material together is called gravity. Number 3, according to the diagram on the right, this is the HR diagram, the Hertzsprung-Russell diagram, and we're going to dig into this in another day's assignment in more detail. But for the moment, this is a luminosity versus temperature diagram. And according to this diagram, all newborn stars, no matter how big they are, can be plotted on which part of this diagram? And the answer is the main sequence. You can see right sort of in the middle there is our sun, right in the middle of the main sequence. Number 4, inside new stars, temperature and gravity bring particles together to generate energy by changing the element hydrogen into the element helium. As you can see on the right-hand side, this is nuclear fusion, and this is the process that our sun undergoes in its core. Hydrogen plus hydrogen equals helium plus energy. This process, which creates the energy that powers every star by converting lighter elements into heavier elements, is called fusion, nuclear fusion. Number 6, the property of a star that determines how it lives its life is its mass. And the mass of an object is the measure of the object's inertial property, or the amount of matter it contains. It is not the weight. The weight of an object is the measure of the force exerted by the object by gravity. So we are talking about the mass is what determines the life cycle of each star. Number 7, these stars do not explode because of a balance between what two forces? And those two forces are the gravity that is holding them together because they have so much mass. Remember, most of the mass in our solar system is in our sun. So there's an enormous amount of gravity in a star, balanced by the energy being created by the fusion reactions in the core. So there's a balance there, and that's why they don't explode. Number 8, when the first fuel runs short in the core of a star, the star will then use a new source of fuel to generate energy. The new source of fuel, once the hydrogen is burned out, remember that's the first element on the periodic table, the next source of fuel will be helium. So our sun is currently burning hydrogen in its core. Eventually it will begin to burn the helium. Number 9, the new substances that will be created once a star begins to burn up all its helium and can continue are carbon and oxygen. And those heliums create carbon, oxygen, and energy. When this happens, the size of the star will expand. The star, like the sun, will then become a red giant. Stars like the sun will then lose their outer layers and form a planetary nebula, one of the most beautiful celestial objects we can see, planetary nebulas, which will expose the center core of the star, which is known as a white dwarf. That's just the remnants of a sun that has gone red giant, and its outer layers have dissipated, gone out. What's left is the core, and it's called a white dwarf. Eventually, these stars will cool down so much they will condense into a dark solid object called a black dwarf once they completely cool. Number 14, stars on the main sequence that are much bigger than the sun have much more mass. So they are higher up in that main sequence. They have more mass. Number 15, they will create elements all the way up to iron. Fe is its symbol on the periodic table. When the star grows to be called a red supergiant, that's when they can start forming iron. These stars end their lives in an explosion event called a supernova. And beautiful remnants of a supernova over here on the right. The object that is left will form one of two things, either a neutron star or a black hole. Activity B, processes and formation of the sun. So what makes the sun shine? You can use this link right here, the star life cycle, or Google search to find the answers. I'm going to also walk you through it right here. So number 18, prior knowledge question, what are the 3 phases of matter commonly seen on Earth? And of course, solid, liquid, and gas. But there's a fourth phase of matter that's actually dominant on the sun, and it's called plasma. So number 20, in a plasma, electrons are free to roam and are not tied to a specific element the way they are in the solid, a liquid, or a gas, in those three phases that we generally see on Earth, at the temperatures and pressures of Earth. On the sun, it's hot enough, there's enough energy where we actually see a plasma where those electrons are free to move through the whole entire plasma. Number 21, how hot is the surface of the sun in Celsius and in Fahrenheit? I'm going to go ahead and let you Google search that and put that in for your answers to number 21, A and B. Number 22, what process creates energy in the sun, in our sun? Fusion, nuclear fusion again. During the process, what element, B, is being fused to create a new element? So B, hydrogen, is being fused to create a new element, helium. 24, what part of the equation represents the light we see coming from the sun? And of course, that is the energy that is released from that fusion reaction of hydrogen atoms. Number 25, looking at the equation next to number 21 and 22, what do you think are the two most abundant elements in our sun? And the answer, of course, is right there, hydrogen and helium. Number 26, what process creates heavier elements in stars with larger masses than our sun? And the answer again is the same process. It's still nuclear fusion. Number 27, what are the heaviest elements created in the star shown to the right? The heaviest elements created are iron and nickel. Iron and nickel, that's how high up it can get in this star on the right. Look at the core. Incidentally, that's the same composition as the core of our planet, Earth. So those iron and nickels that are now forming the core of our planet were actually formed in large mass stars initially. Number 28, a hydrogen bomb is also the result of nuclear fusion. So why doesn't the sun explode like a hydrogen bomb does? And the answer is because in the sun, there's a balance of forces between gravity, that immense gravity forces from all the mass in the sun, versus the energy released from the fusion. In a bomb, like a hydrogen bomb, all we have is the energy. We don't have that intense gravity to keep that explosion under control and balance it. 29. What is the name of the object that forms like a star but is too small or has too little mass to actually start nuclear fusion? And we call those brown dwarfs. So they kind of are failed stars that never really get going. They never get their fusion engine running. Number 30, name the layers of the sun that are A, the energy producing layer. Okay, that would be A, that would be the core. That's where the fusion reactions are happening. B, the surface layer that light comes out of, that would be the photosphere. That's the lowest of the top three layers that we can see. And C, the outermost layer, the atmosphere of the sun, we would call that the corona. How did the sun in our solar system initially form? And here is a good video you can click through on this to watch. Number 31, inside the right type of nebula, globs of gas and dust form, which are baby stars in the making. At this stage of formation, they are called protostars, and those were up in that initial diagram that we talked through. Number 32, what is the name of the theory for how our sun and solar system formed? And the name of that theory is depicted here on the right, and it's the solar nebula theory, solar nebular theory. Number 33, what are the three main stages of formation of the solar system according to this theory? First is cloud collapse. So you have this cloud that starts to collapse due to gravity. And then we have the formation of a protoplanetary disk. So that mass at the beginning, we have a sun forming in the middle. We have protoplanets around the outside. And then the third stage is the growth of planets, as that material that's orbiting the sun that's forming in the center start to accrete, clear their lanes, and form planets. And that is the solar nebular theory. And number 34, last question in the assignment, when did the process of solar system formation occur for our solar system? In other words, how old is our sun? The answer is it is about 4.6 billion years old. That is when our solar system began to form. Thank you.